your engineering career progresses and you start out being very wedded to like individual tools and ideas. And then like at the end, you're like, you know what, it all sucks. And just a question of which way. So like, why should I care about that? Let me think about things at a higher level.
Welcome to the / podcast, where we lean into the future of IT by inviting fellow thought leaders, innovators, and problem solvers to slash through its complexity. I am your host, James Carman, and today we're talking to William Morgan. William is the co-founder and CEO of Buoyant, the creators of Linkerd. Before Buoyant, he was an infrastructure engineer at Twitter, where he helped move the company from monolith to microservices, an experience that led him to co-create the term service mesh. I didn't know you were the co-creator of that. That's pretty cool. The architecture that powers today's cloud-native applications. He has been a passionate contributor to the open source community for over 2 decades. Welcome to the / William.
Howdy, James. Thanks for having me.
That's cool. So you helped coin that phrase service mesh. I did not know where that came from. That's cool.
Yeah, well, now I regret it because that's going to be like the thing written on my tombstone. But yes.
Well, it's pretty important. I think it's the concept and the pattern has contributed tremendously, especially in the Kubernetes world. But I mean, just even in broader terms, maybe explain what is a service mesh. So there are some folks that may be listening that don't know what a service mesh is. Let's at least hit that real quick.
Yeah, sure. So, if you're in the Kubernetes space, you're probably like sick to death of this term. And if you're not, then like it has no meaning whatsoever. Right. But the idea is that it's basically a layer of infrastructure that sits kind of in between where the application is and the underlying network. And it does what I would roughly classify as application level networking. So it handles things like, how do I do retries and timeouts? How do I secure a connection? How do I load balance individual HTTP requests instead of connections? And the goal is that you should be able to add a whole host of reliability features and observability features and security features to the platform without having to change application code. So it is this kind of collection of features, but they all sit at this one specific layer of the stack, which is in between the Kubernetes cluster and the application. So the developers, the goal is like the developers don't have to care about this or even know that it's there, but they get to benefit from it because they don't have to write this complicated, distributed systems code around like, how do I do retries correctly, in a big multi-step microservices environment, or how do I do TLS correctly, right? Like you can offload all of that to the platform. So that's a service mesh, yeah.
And would you, I don't know, there's some of this, like, I always think of, when I think of service mesh, I think of what the, folks characterize as that east-west traffic, like within the cluster. But is the ingress, is it also part of the service mesh's responsibility, or is that a different thing?
It can go either way. Some service meshes pull that, kind of have a default ingress. So ours, which is called Linkerd, which is the first service mesh, and the one to coin the term, and the first one to achieve graduated status in the CNCF, and all the other cool stuff. We did not ship an ingress layer by default because we were like, well, we're going to follow the Unix philosophy. We want to be small and self-contained and do only one thing, and so we'll play nicely with whatever ingress you have. But you're right that kind of east-west traffic. So you think of north and south as like coming into the cluster, is north, and like going out to some database maybe is south. East-west is all the communication that's happening between the services. And that's the change that happened, now maybe 10 years ago.
Yeah.
But that was a big change that happened in cloud native, services, or in microservices, was just the introduction of that class of traffic. Prior to that, you'd run these 3-tier applications where you'd have like a big proxy in front. You'd have the application as this one monolithic code base, and then you'd have the database, at the bottom. And so that application got split out into tons of different services, and there was this new kind of communication that happened, and that's when the service mesh suddenly became relevant.
And you, in your bio, you mentioned your time at Twitter. So was Linkerd, was that kind of born out of Twitter? Is that where that came from?
Yeah,
Okay.
no, exactly right. Because Twitter, when I started, and this, a long time ago, right? 2010 was when I started there. It was a monolithic Ruby on Rails application.
Whoa.
And by the time I left, 4 years later, a lot of what I had done was helped turn that monolithic Ruby on Rails app into this big distributed system, what we would now call cloud native, even though the components were very different. So, split it up into a bunch of different services. So now instead of having function calls where like, method A calls method B calls method C, well, now you've got these like network calls that are happening. Service A is calling service B, calling service C. That was written on the JVM and in languages like Scala. It was packaged up. We didn't have Docker, so the JVM was kind of our packaging mechanism. It was running on Mesos, which was a big distributed systems kind of orchestration platform. In some ways, a predecessor of Kubernetes. A lot of the lessons that we learned collectively during that transformation, especially around the management of this new type of communication that happened, went in to become the thought and early on the actual code behind Linkerd. When we started that project, we literally took a bunch of open source Twitter libraries, that navigated that east-west communication, bundled them up as a proxy, and that was Linkerd. Now we later had to rewrite it for a variety of reasons, but yeah, that's exactly right. That was the impetus for all of it.
Okay. And I know we want to talk about different things, but it would be crazy for me not to ask you about these sort of things. So you mentioned like the monolith to microservices, and I think Linkerd and technologies like that, and the CNCF ecosystem has been big on this trend of monolith to microservices. But now there's kind of this like counterculture. There's like this back to the monolith thing going on. What do you think about that? I don't think we didn't go crazy like we normally do, where it's like, overcorrection back to like, combining everything back together. But like there was a bit of this pushback on that microservices era. What are your thoughts around that? Is it well founded? Is it just FUD? What do you think?
I mean, I think it's like any engineering decision. There's a bunch of trade-offs involved. And so it's not like you move from monolith to microservices and life is suddenly better. You've introduced a whole new set of complexities. Right now you have a service mesh that you have to like think about, right? You never had that. You had function calls where like A calls B calls C, right? What do we know about function calls? Well, they work all the time, basically, and they're very, very fast. And now you've replaced them with network calls that like fail half the time and are slow. So you've introduced a whole bunch of complexity. What have you gained, in exchange for that? Well, you've gained these separate units that are deployable, that are owned by individual teams. And so now you can have a team that owns, service A, right? And can deploy it on their own schedule. And so you've earned this, this kind of autonomy that you didn't have before when everything had to merge into one big code base. Is that good? Well, it depends, right? At the scale Twitter was, it certainly was good. And there were other reasons why Twitter went down this route. Like one was just pure scalability. We were pushing the limits of what Ruby could do and what the hardware could do. So we had to split things out, for those reasons. So it gains you this autonomy of teams. It gains you the ability to scale different parts independently. So, one part of your code base might be very simple. Another part might be really load bearing. And now you have, if you can turn that into a separate service, well, now you can scale up to 1,000 replicas of that without having to scale everything out. Right. But you're adding all this complexity. So it depends on the situation you're in. And I think like anything, when there's a new shiny, tool or way of doing things, people go overboard and you end up in situations where you kind of push it to an extreme and you're like, oh, okay, maybe I don't need, I've got 100 developer teams and I've got 10,000 services. Well, probably is like doesn't really make a lot of sense. But it's, so I don't want to say that pushback was unwarranted. I think it's a natural kind of course correction. I will say when you look at how services or how software is built today, when you're doing it at kind of a non-trivial scale, the majority of it is built in this multi-service way because it makes sense. And also a lot of the the friction around doing things that way has been paid down pretty dramatically by things like Docker and Kubernetes. But it's not the only way. And I wouldn't, I was starting something, I wouldn't start there.
Yeah. It was funny when like the whole microservices thing, people would kind of look at me funny. I'm curious your take on this, but like I always said, like, to me, what I saw as the major benefits of kind of microservice, there are technical benefits, of course, but I think the major benefits were more organizational in nature. As you were saying, like you can split up teams, they can be more autonomous, they can do their own thing, and you don't have that massive coordination. To me, that was the biggest benefit, in my opinion. That's what I always saw. And people kind of always looked at me like, what are you talking about? This is a technical thing. This is not organizational, but I don't know. It always felt that way to me.
Yeah. I mean, the whole software engineering discipline is about the intersection of humans and computers, right? Or teams and computers. And
right.
Like so much of what you do when you're working in the context of like, if you're a professional software engineer, a lot of what the decisions you're making are around how other human beings are going to interact with what you're doing. So they're not, I wouldn't say they're purely technical decisions. And I think maybe I'll be a little critical there. I think that's a pretty junior point of view to be like, oh, these are technical opinions, right? This is not a thing where we care about the people, right? Like the moment you have more than one person involved, now you're caring about the people. So you have to take that into account.
Until, AI takes over everything and then we don't care about people anymore. Then who cares?
No, I mean, that's right. We get a chance to reevaluate some of these things in a world where AI is taking over.
Oh, all right. The Kubernetes is, I'm a huge fan myself. I've been around, and I want to make sure I've said it a couple times already. Linkerd. Am I pronouncing that right? Because I've heard other people say like Linkerd and
Linkerd.
Linkerd
rhymes with Cardi B.
Oh,
it's in the FAQ, in the FAQs. Says
Cardi
right
B. Okay. All right. Good. I'm glad I was saying it right. So I know somebody.
And the etymology there, if you are a deep Unix nerd, it'll be very natural for you, which is like we add a D on the end to anything that's supposed to be demonized, which means it's like running in the background. It's not a thing that you as a human are like, it's not waiting for your input. And kind of the analogy we'd had in our brain was in operating systems, there's loaders and there's linkers. And so when a binary gets like pulled into memory and it has these dynamic libraries that it's depending on, you have a linker that basically does, that, and a loader that, pulls in the right library code and does it seamlessly without you, as the user having to do anything. And so we kind of had that analogy in mind. We're linking these microservices together. We're making it so that if I'm A and I want to talk to B, I just say, hey, give me a connection to B, and I don't have to care really about where B is or how many instances there are, or is it busy or not, or is it secure? What? Like I say, hey, give me that thing, and Linkerd will figure out the details. So that's the origin of that name.
That's cool. Service mesh, when it's one of those things that like when you look back on it and you look at what how it was, how it came to be or how it's manifested or whatever, you're like, wow, that totally makes sense. And it seems like, oh, well, this is just obvious. What was that journey
there were
like?
Some geniuses involved. I mean, gosh,
what was
real
the
visionary
journey?
people.
How did the journey happen to get to where you understood, like, okay, if we put these proxies in here, we got this, we can almost create this substrate here and we can plug things in dynamically and people don't have to worry about it. How did that evolution happen? I don't know, was it an aha moment or was it just like this evolution over time? How did that happen?
I mean, just sheer unadulterated genius from beginning to end. It's a series of happy accidents, I think, is what it came down to. We started out, at Twitter, we didn't have Linkerd or a service mesh. We had a bunch of libraries that we engineered to do this. And so the first version of Linkerd, our only kind of moment of inspiration was to say, hey, Twitter's doing this, but it's doing it with a Scala library. And like the intersection of people who care about both Scala and distributed systems at that point in time was like, zero, or maybe like the engineers at Twitter and no one else. So we said, okay, well, let's pull this into a proxy. We'll forget about all the cool programming nicenesses and, functional programming and, flat maps over RPC calls or whatever. Like, we're just going to give you a proxy, and then, you stick that thing next to whatever application you have, and the devs are going to be, are going to be unaware of it. And so that made a lot of sense. And then we did that at a time where Docker was starting to really, come into play, and Kubernetes was just getting started. And suddenly all these other conditions were right, or ripe for people to write multi-service systems. And so once we had that realization, we were like, oh, Kubernetes is the thing we should target. Mm-hmm. And then, we were like, oh man, running the JVM on Kubernetes sucks. And no one in Kubernetes, people at that point were writing these like Go microservices, right? And they would take like 50 megs of memory, and we were taking the JVM, and we were like, okay, we're going to turn this thing into this like proxy. And we're like, hey, it's really transparent and seamless, but it was running at like 150 megs or more. So,
if you're lucky.
yeah. I mean, we had to work hard to get down to, because it wasn't just the JVM. It was like Scala libraries and all this stuff. And, JVM, love it or hate it, it's great at scaling up, right? But it's not good at scaling down. And we were trying to encourage this model where you would distribute these proxies next to every application pod. So, you couldn't quadruple your memory cost. So we ended up having to rewrite it. So we rewrote it in Rust for the core proxy, and then the control plane, which is kind of the management piece, we rewrote in Go, because it was talking to the rest of Kubernetes. And so just, one step after the next. And then we also had to pick a name for it, because when we started out calling this thing like an application proxy, we didn't really know how to frame what we were making here. We knew it worked. We knew it was a good idea, but people would be like, I already have a proxy. Like, what are you talking about? I use Nginx, or I use Apache. So we had to invent a term. We invented service mesh because it was like a meaningless term, but it sounded cool, and it gave it a name, and it was like this white space where we can now say, oh, what is Linkerd? It is a service mesh. What does that mean? Well, here, let me tell you. And once you kind of like got that idea into people's heads, well, now it started to make sense, and now you could it was easier to distinguish it from their existing proxies, which were, in fairness, used for totally different things. So it was a series of things like that. Yeah, in retrospect, of course, it all looks pretty easy and straightforward, but it was not. And a lot of it, the plan changed as we went along.
Yeah, it's funny when you look at those things, and it's very elegant and makes things seamless. You look at it, and you're like, oh yeah, I could have figured that out. No, you couldn't. No, I wouldn't have figured that out. That's pretty cool stuff.
I mean, maybe a lot of it was the product of the environment, right? And us just being in this situation at this point in time, and just trying to, if we had any skill, it was just trying to understand and listen to and observe like what was happening with this thing we were saying, and then being willing to change it in response to that.
So you brought up Scala. So I'm a Java guy, a long time on the JVM. I did a lot around Java, but Scala, I love Scala as a language, but man, we just, at least in the circles or the areas where I've had experience, it just didn't take off like I thought it would. And I feel like the community around Scala was very cerebral. I mean, as you said, they were talking about, flat map and monads and all these. So they're very functional programming. They're very cerebral, very almost academic sounding in nature. Yeah. How did Twitter arrive at Scala as it's at some influential engineer was like really into that stuff and was like, hey, this is what we're going to use, and get on the bus or get off the bus. And that's really all it came down to. I was a Ruby guy. I was like, I came to Twitter because I love Ruby. Oh, this thing's all written in Ruby. And then they were like, no, we're going to move on to JVM. And I was like, oh. What?
I think I sent an email to the entire engineering department being like, don't let them do this. I got in a little trouble for doing that. And then finally I was like, okay, whatever. Like it's, again, there's like, you go through phases as your engineering career progresses, and you start out being very wedded to like individual tools and ideas. And then like at the end, you're like, you know what, it all sucks. And just a question of which way. So like, why should I care about that? Let me think about things at a higher level.
I so hope that's the pull quote for this episode. At some point, you realize it just all sucks, and oh, that's funny.
Yeah, it's just a question of where you're putting the sucking.
I always heard because I love Ruby too. I thought Ruby was a fantastic language. There's a few things I didn't like about it, but I mean, from a broad standpoint, I love Ruby as a language. Whenever you would hear people talking about, oh, you shouldn't use Ruby because it doesn't scale, Twitter was always like the counterexample. Like, what? Well, they're using it at Twitter, so it must scale. And then there was a further on conversation that they were doing something different. Like there was some sort of like binaryization of Ruby going on there at Twitter. Is that true? I don't know if I've ever validated that claim. People said like they were compiling it or making it like there was an optimized interpreter, or I don't know, something.
Yeah, I'm trying to remember. I think we were doing a bunch of stuff like that. We were, we had folks with getting deep with the Ruby interpreter. There was like a kernel team, like we were doing, there was some serious systems programming going on in there. I don't think the scaling factor that really was killing us though was the choice of language. I think it was more at that point in time, we were really hardware constrained. Like at the data center level, we were locked into the situation where we could scale this more by adding more machines, but they literally didn't have more machines to give us. And the nature of the application, you had these very asymmetric situations where you and I would tweet, where you would tweet and you have like 10 followers, like who cares, like zero impact. But then Oprah would tweet and, a trillion timelines would have to, I don't know, like 500 million timelines would have to be updated. And so the magnitude of kind of the difference in the many orders of magnitude of difference between different activities or different people, really that put a lot of stress on the system and the way it was designed. And I think there were some design choices, early on that weren't really expecting people to have hundreds of millions of followers. And that was really the stress point. So I wouldn't really blame Ruby. It's not the fastest language in the world, but like that wasn't the thing that was really killing Twitter at that point.
That is an interesting problem, though. I mean, you think about like, oh, posting a tweet is you're just posting a tweet, but it's not. It's, as you were saying, like me posting a tweet, Twitter's not going to sweat at all, right? Nobody's hearing it. That's like me going out in the woods and yelling. It's like, who cares? But yeah, like Oprah or somebody big like that. Yeah, that's really an interesting problem.
There were all these famous moments. I mean, this is like a fun time to be there because there were all these moments where, gosh, what was it? It was like the World Cup was happening in I don't know, when was that? 2010, sometime between 2010 and 2014. Maybe it's 2010, there was a World Cup. And every time someone would score, like the site would fall over because everyone was tweeting goal.
Oh my God.
And there were so many tweets of, we were just like running on the edge at every point. So, I came in there being like, hey, I want to write Ruby and like everything else sucks. And after a little bit of that, I was like, okay, we got to figure out how to keep the site alive, right? Like, that's like level 1 of Maslow's hierarchy of SaaS applications.
All right, so Twitter's that is a fascinating story, and a lot of people, that's one of those companies that people are like, oh, like what would Netflix do or what would Twitter do, or all that. So it's good to have that context, and that's interesting that they have way different problems that a bank or whoever would have. So. Now, Kubernetes, though, the world of Kubernetes, I think, is it pretty well established that this is the platform? Like, if you're doing modern software engineering, I kind of feel like the Kubernetes is like a done deal. It's like settled science kind of level thing. Are we there? Are there alternatives right now that are in any way, shape, or form like going to knock it off its pedestal? Like, where are we?
Yeah, no, that's a great question. I mean, Kubernetes just celebrated its 10-year anniversary. And so I think for many technologies, that's kind of like, that would indicate it's time to put you in the retirement home. And yet that community, continues to grow and the usage continues to grow. And so it seems like whether you like it or not, it's kind of here to stay. And, I cut my teeth on Mesos. So when I came to Kubernetes, I was like, oh, this is like not as good as Mesos. But now, again, like, what do I care? Right? It's like, it's the thing, it's there. What does it solve? It solves an important problem, which is like, I don't want to have to care about individual machines. Like, just you take care of that. And, just give me a thing where I can say, okay, I want 6 of these and I want 12 of these. And this one's a database and this one's like an LLM or whatever. And like, you just figure out the rest of that crapola. And that's what it does. And I think now at this point, yeah, I hate the term de facto standard because I almost always see that in like a marketing context when people are trying to say, well, our solution is a de facto standard. But I think in this case, like Kubernetes is kind of the de facto standard. Like what else? Yeah, what else would you use? It's not zero cost, right? It introduces a bunch of abstractions and a bunch of like things you have to learn. What's the difference between a pod and a deployment and a replica set and a rollout? Right. And like you have to have that ontology mapped out in your brain. And so there's a cost you pay up front to being able to use it. But I will say, in Kubernetes' defense, and people always say Kubernetes is complex. In like a pejorative way, my sense is like Kubernetes is pretty well designed. Yes, there's things you have to learn, but they all make sense and they compose nicely with each other and they've been thought through, and you can like assemble the pieces in a way where it feels coherent at the end. So I don't think it's complex. I don't think it's like trivial. I don't think it's zero zero cost to get started by any means. You have to learn some stuff, but it kind of makes sense. And so, yeah, to answer your question, I haven't seen a big desire to move off of it, because it just kind of works.
Yeah.
And at this point, the ecosystem has absorbed enough of it that it's everywhere. And like everything you're running has like a Helm file. Every piece of software probably comes with a Helm file. And yeah.
Yeah.
Is that what you want to innovate on, or do you want to like move on to the more interesting stuff?
Right. You want to write your business's software, or do you want to try to write the glue? Like, the glue's there already for you.
Again, if you were starting something new, right? Like, would you start with Kubernetes day one? I think it's an argument that no, you wouldn't. You would start with something simpler, but I would expect us to hit Kubernetes at some point. By the time you have more than 2 people, 2 or more people like trying to use the same set of machines. You're pretty close to wanting Kubernetes.
Well, it's funny, when there are simpler situations, like I think we're running one of our internal things as like an app container or whatever or container app, in Azure. But like underneath the covers, all of those technologies are usually just kind of a wrapper around Kubernetes anyway. Yeah. So it's Kubernetes all the way down, right? I'm with you on the complexity thing. Like I know early on, I came from like a Cloud Foundry background. That's where I started with my container world. But and moving to Kubernetes, it did seem complex at first. But you're right. Like once you do wrap your head around it, it's kind of elegantly simple. Like the whole nature of like, we just declare these things, these resources, and then the cluster takes care of converging it on the state that you say you want it to be in. That is a really liberating approach, I think. Anyway, I'm with you. I agree with that. I think of the tooling around Kubernetes is so advanced now that it's there's no excuse there. Anyway. You mentioned when you were talking about Kubernetes and running things in the database here, but you threw something in there, LLM. So that would be interesting. What is the Kubernetes picture now? You do hear people bringing up Kubernetes as almost being like kind of the substrate or the foundation that we're going to run all these crazy AI workloads on now. What's your experience there? Do you think that that has some legs to it, or what's your experience around that?
Actually, I think that's a great example of why Kubernetes is kind of like the de facto standard. Kubernetes doesn't actually give you a lot for LLMs. Right? The way, if you're running an LLM, like forget about training, because training is like a whole different activity. But if you just want to run inference, you want to boot up the LLM or SGLang or TensorRT LLM or like any of these things. The way those things all work is they want full access to however many GPUs you have on your node. Like that's what they want. And they want to take the whole thing and they want to, just max it out. So like, and they want to stay on that machine, right? Like they're using every bit of the GPU memory that's possible. So like Kubernetes gives you very little, it gives you basically nothing in that situation. And yet it kind of is, the place that everything is happening, because what's the alternative? Well, there actually, I guess there are alternatives in the machine learning world, but by the time you're trying to run inference, it's all happening on Kubernetes, because like, where else would you go? So there's not a compelling reason other than like, I don't know, what's the alternative? As far as I can tell, that's kind of why it's happening there. And so all of the inference stuff that I'm working on, like, we're targeting Kubernetes because like that's where it's going to happen. Is it for good reasons, or is it just because that's how the world has evolved? I don't know. I run around all day with like an appendix in my body that has no purpose, and yet, I'm not trying to innovate on that.
I just leave it there. I haven't really messed with it at all.
I'm just trying to ignore that.
Yeah, it's fine. Oh, so there's from the inference side, so actually running an LLM, running the model, and sending queries to it. Not a lot of gain there. Now, what about AI enabled workloads? So if I'm let's say the LLM's running somewhere else, but I want to run a workload that leverages that LLM. Is Kubernetes particularly adept at those workloads? Does it lend itself to it, or is it just, again, the day fact? Where else are you going to go with this?
There's some interesting stuff people have been digging into around sandboxes and being able to provide agents with like this much more secure environment than what a container is. A lot of that is happening on Kubernetes. So that's one aspect where I think, yes, there is some innovation that's happening. But apart from that, I mean, a workload that uses inference is just a workload. Right? It's just like some code that runs and like it talks to some service and it gets something back, and then it like does something else. So, Kubernetes is valuable to the extent that it's valuable for any workload. Again, with that sandbox thing being something that's, I think, pretty interesting, because it's very, on the one hand, it's just, an agentic workload, it's just a regular workload. On the other hand, it's like, it's one that you don't really trust.
Right.
It's one that's almost by definition doing non-deterministic things, and it's going to look, it's going to eventually find, if there's a way to delete your database, it's going to find it and it's going to call it. So, yeah.
Do you think it's because there's been a lot of work around like, kind of the policy as code and integrating policies into the cluster. Is that kind of what they're leveraging? Are you standing kind of on the shoulders of those giants to kind of control and sandbox these things? Is that what you're referring to? Or
I think it's more than that. And I'll quickly admit, like, I have dug about 1% into this, so I don't really know the details, but I think it's a much stronger set of guarantees than that around how do we truly prevent a non-deterministic workload from being able to access anything else in the cluster.
Gotcha. So you're highly involved in the Kubernetes kind of world, in the ecosystem. You're in the CNCF. You're involved there. What's the next big thing for Kubernetes? I mean, obviously AI is now, and we're kind of getting into it now in Kubernetes. But what is on the horizon? What do you think is that next era for Kubernetes?
There's only one answer to that, and you've already said it, and it is spelt with 2 vowels.
Just AI.
Just AI.
Just AI.
It has eclipsed everything else in the universe, other than like peptides, I guess.
If you could combine a business for both, man, you just print.
Yeah, I'm sure it's out there. I'm sure it's doing super interesting stuff. Yeah, peptide design. I mean, DeepMind was some of the early successes were around like protein folding and stuff. Yeah, we're using it for like customer success chatbots or whatever, but like, there's way more interesting stuff we could be doing with the same core technology.
So you think that is there anything around like is quantum even anything that the Kubernetes world is whispering about at this point, or is that kind of a pipe dream kind of a thing still?
Not that I have seen. Maybe it's out there and I'm just not exposed to it. I've seen, certainly from the perspective of Linkerd, which does TLS, we've updated, the TLS components to be quantum proof, to use algorithms that we expect to be, still valid cryptographically after some quantum, improvements happen, which may or may not ever happen. But other than that, I think I haven't seen a lot of that.
Yeah, I found it funny, the standards or whatever around like the post quantum cryptography stuff. I mean, you would think that cryptographers and people in that world would be they're kind of geeky folks, right? Anyway, but then they went and chose kyber and dilithium, the two crystals, as what they named their standards after. I'm like, how could you get any more nerdy? Like, seriously, like you're giving us a bad name here.
Yeah.
Come on.
Yep. Yep.
Anyway,
Not doing yourselves any favors with that.
no, you're not.
So
You're not trying to
this is
cool
like
yourself.
all like science fiction / fantasy stuff that we're talking about, right? Like,
yeah,
is that the analogy you're drawing here? Like, we're going to use the force, and
yeah, we're using lightsabers to protect our data now. Yeah, sure. Okay. Well, this has been a wonderful conversation, a great conversation. I'm glad to have someone who's so involved in the Kubernetes ecosystem with Linkerd and Buoyant, the company. We have to move on though to our ship it or skip it segment.
Ship or skip, everybody, we got to tell us if you ship or skip.
So the idea here with ship it or skip it is that we come up with a topic and we say, oh yeah, go with that, ship it, that's good, or skip it, that's bad. It's our hot or not. It's our take on our hot or not. First up, let's talk about. There's a lot going on in this area. You hear a lot of talk about this, about AI taking our jobs. Anything interesting there for you? Do you think that AI is going to take people like your job and my job, or is that just FUD? Where are we at with that? What do you think?
If I say ship it, am I endorsing that idea, or?
Well, okay, let's say ship it means I think that it is going to take our jobs. Skip it, like, no, that's BS.
I have a more nuanced answer than a binary one, which is
most architects say it depends. That's what we always say. So yeah, I'm totally on board with that.
I think there's two levels to this conversation. The first is what's happening today, and I think if you spend time as a software engineer with something like Claude or any kind of like AI development stuff, you will quickly realize that there's the writing of code is now a thing that you can hand off pretty effectively, but there's a lot that you cannot hand off right now. There's a lot of decision making that you have to do as someone who's driving Claude. And there's a lot of like thinking, in some ways harder thinking, because you have to do it more frequently than you had to in the past, around like, what am I actually trying to do here? And like, what trade-offs am I willing to make? So I think from that perspective, no, AI isn't taking our jobs. If anything, it's like this amazing tool that allows us to operate at a higher level. We've all shifted up one level of abstraction. So I think that part is cool. Now, the other layer of conversation, though, is okay, if you look at the pace of advancement, from what AI has been able to do over the past couple of years, it really is astonishing. And if you play that forward, then is there anything that really is going to stop AI from being able to do this next level of stuff, right? The things that I'm doing today with Claude, where I'm like thinking through the design constraints and trying to figure out, okay, what is important and what isn't important, and what's the interface that I want. Is there anything that stops AI from being able to do it? Well, okay, maybe not. And what about like the higher order decision making? What about like, me as a CEO of Buoyant? Like, I'm making decisions around how do I invest in, how does Buoyant invest in this opportunity versus that one? Like, which part of AI is like good for us? Is there a reason why AI couldn't do that as well? Okay, well, maybe not, right? Like, things are advancing so fast. Who can say, okay, well, then what's the point of any of these jobs? Like, what's the point of having a CEO? What's the point of why isn't this company just a bunch of AI things? And like, that's going to happen to our competitors and to our customers. So, logical conclusion is we're all just going to have like AI bots talking to AI bots. And then like, what's the point of any of this stuff? Like, how does the economy work?
Yeah.
What value do humans have at all here? Right. And that's the train of thought, which is scary. And also it's really hard to navigate, because like you've kind of taken off any kind of constraints or rules on here. Like, I guess property is still like a thing we have to defend. So maybe guns are useful. Okay. But what else? Right. Like that part, I don't have a great answer for, other than kind of an optimistic vision that like, it's not that we don't have imminent societal collapse, or at least the probability is not at 100%. I think that's a harder thing to answer, though. Yeah, is AI coming for our jobs? I don't know. Like, one answer is all society is doomed, and so yes.
Well, I'm with you. Like, I think there was a study, Harvard, somebody like that, not too long ago. They talked about kind of like you're saying, if you keep pulling that thread, like, oh, we're going to replace jobs, we're going to replace jobs. You keep pulling that thread. Okay, fine. Nobody's working. Well, who's going to buy your service? Who's going to buy your product? Like, nobody's going to be money. Like, this just devolves into like chaos and just into a bad place. So I think we have to. Obviously, that's not the way we want to go, but people keep pulling on that thread, it seems. So I think there's going to be. I don't think we've hit it yet. I think we're kind of. I don't know. I feel like we're like monkeys who have stumbled across like a hammer or something, right? Like we realize, oh, there's a tool here, and we're just floundering around with it. We haven't realized, what can I really do with this tool yet? I don't think we've hit that aha moment with AI yet.
Or we've stumbled across a chainsaw and we're like,
that's probably a better analogy.
Makes a fun sound over here when I use it to answer customer success, questions.
That's
what happens when I put it over here.
Yeah, that's a better analogy. But I think that's the idea. We haven't had that aha.
Yeah, and I do understand the angst and the and I share some of that around this question, because it's in a world where you have like taken off all constraints and you're like, you don't know what's been possible. All you know is like progress is happening incredibly quickly. And then, it is hard to have any kind of mental framework around what's going to happen.
Yeah, it is. It can be a scary conversation for sure.
Yeah. So stock up on ammo and Bordeaux. My advice.
That's a true Texan right there.
Well,
get you some Lone Star beer and some ammo.
Yeah, exactly. I'll be fine.
No problem. We'll be good. We do that in Kentucky too. I shouldn't say that.
Okay.
Okay. So you mentioned working with Claude, pair programming, like using these tools as kind of your pair programming partner. We hear a lot of people talking about there's been a lot of stuff lately about like loop engineering is kind of the next phase of this. We were the aha moment we've had with using AI to help with software engineering, like loops and setting up loops, and these things just keep on moving and everything. I've said for a long time, I think the superpower of the future is how are you going to keep the agents constantly running? It seems like this loop engineering thing kind of is going in that direction, from at least from a software engineering standpoint. And there's loop engineering for agentic workflows, but I'm mainly hear it around software engineering about creating these loops. What are your thoughts? Is this the future? Is this just a stepping stone to the next thing? What do you think around this loop engineering thing?
I think it's an interesting thing to explore. I think it's a stepping stone, maybe. Like at its core, it's not really any different from how you're interacting with something like Claude today, right? You tell Claude something and it goes around and does a bunch of stuff and then comes back and like the value of what it does and really comes down to how well have you specified the problem and how accurately can you give it a framework by which it knows, yes, this is good and or no, that's not a good solution. And so when you look at what people are doing with loop programming, that really is the deciding factor as to whether this loop is actually useful or not. It's how well can you specify, this is the goal and this is how to know whether you've hit it or not. And some problems is very clear how to do that, and you can be pretty successful, and you're just like, okay, keep going over and over again until you can't do it anymore. If you can't do that, well, now you've got a human in the loop, and you're kind of human in the loop. You're kind of in the same situation you were in anyway. It's like the hard parts of all this stuff are figuring out what you want, right, and being able to describe it. Which, by the way, is like the same problem that programming has always had, or any kind of engineering has had. It's like figuring out what you want and being able to describe it in a way that's like sufficiently detailed that whatever system you're using, can deliver a solution. So I see it as it's like an interesting thing. I don't think it's any more transformative than the rest of AI has been.
Yeah, I think that's fair. I think anytime we try to like remove feedback loops, we start to get into dangerous territory, because there's got to be some feedback in that loop of the AI going off and doing things. If you just leave it at its own devices for hours and hours on end, it can get off the rails. It can do stupid things much more quickly than we could. Right. That I think there, as you said, that human in the loop still has to be involved. That judgment still has to be involved. But I don't think the loop. I don't think the loop is, as you said, there's nothing necessarily special about this. It's just kind of a stepping stone to the next evolution. One thing that happened, it was like a couple of days ago, or maybe it was yesterday. Elon Musk, he always says these silly things, but one in particular that he said yesterday was programming. It's the whole is dead things, right? Everybody says, oh, so and so is dead. Well, he said programming will be dead in 2026, and what he meant by that is literally writing computer language or software development language is gone. The AI will write computer binary code directly, and we won't have these programming languages anymore. So programming itself is gone. That one, I mean, I've said that we could get there, but I can't imagine that's happening in 2026. I mean, how much I have to correct the AI when it is doing software programming language work.
Yeah, that's if the meaning of that is literally, oh, we're just going to have the AI write the CPU bytecodes directly or whatever. Like,
I think that's what he was getting at.
I don't think that really makes a lot of sense, unless you take a very specific interpretation of that, because right now, the way these LLMs work, they really benefit from as much structure as you can put in place around it. So when I write code with Claude, I use Rust because I'm like, I want the most not complicated, I want the most difficult, strict language involved. And I see it, fail the borrow check and like, oh, I got to fix that and I got to fix that. And I'm like, great. That's exactly what I want. I want as much structure as I can around this thing so that when it's going through its non-deterministic, process, it can be constrained to code that I know is going to be memory safe, right? And if you remove all those constraints, then you're going to get something that doesn't really work. Yeah. So the more constraints you can put in place, the better. Now you can say, okay, well, they're just built, they'll just do all that stuff as part of the AI, like the harness will just validate all that stuff. Okay, sure, yeah, maybe there's a definition where you can do that, but like to me, that doesn't seem very practical. I do think the more interesting thing to consider is like, is there any point to looking at code anymore? Right, like that's one where I feel like we should expect to see a world where you're not really looking at the code. What you're looking at is you're looking at the plan files, you're looking at the documents that describe how the system works, you're looking at the interfaces, but the actual code, who cares? If it compiles, if it passes a borrow checker, like it doesn't really matter. I don't think we're quite there yet. I think there's a couple other things that have to be in place, but that's the level I would expect to get to, which is pretty astonishing, by the way.
Yeah, I think Rust, you bring up Rust, is a particularly nice language for this because it has those extra checks. That borrow idea it's very strict. A compiler is one level of thing, right? And so for compiled languages, it's very helpful. But Rust it is a bit more extreme in that those restrictions about what you can and cannot do and how it manages that. So yeah, I like that. Those guardrails are built into the language and it wouldn't even compile. And I'm with you on the reading code. I do find myself reading code less and less. Now I'll look at the interface level, are the contracts right and those sort of things. But the down and dirty stuff, that is it really that important when the observable outcome? I don't know that I'm quite ready to say just go straight to machine code that I can't understand if I needed to. I'm not at that level of trust yet. That's a little far fetched for me, especially in 2026. I can't. That just seems just crazy. But hey, this all seemed crazy 2 years ago. So whatever.
Well, right. So that's the other thing, right? You got to keep that in mind. Is like, 2 years ago, I would have been like, no, there's no way this stuff is going to work. It's stupid. why are you even bothering?
The thing can't even do math correctly. And,
so I wouldn't listen to any of my opinions. I'm like, I'm wrong. I'm, objectively wrong about all this stuff.
We have we have a conference in town that's a Cincinnati AI Week. So I'm from Cincinnati, Ohio, and we were talking about something on stage, and I was like, what would be interesting is every year when we do this conference, we should have a "That's cute" section where we look back on predictions and things we were talking about and worried about the previous year, and then like just look back on it and be like, "That's cute." Oh, computers are doing all these things now. Like in 1 year's time, it changes that
Yeah,
dramatically.
no, that's a great idea. Look how wrong we were.
Yeah, this is how wrong we were just 1 year ago. All right, token optimization. So we went through this era of token maxing, right? Everybody was they were all bragging about how many tokens they were using, and then they were like, wait a minute, these things cost money, and now everybody's like the pendulum swinging back the other way as this token optimization thing. What's your thoughts on that? Is this like a yes, you should be token optimizing, or do you think this is just like a premature optimization? Or what's your take on that?
I think it's totally normal, and I would think of inference as a resource like CPU, right? Like you start out being or memory or whatever. Like you start out being like, oh my gosh, I have like gigs and gigs of memory now. I can write my application to do whatever it wants. And then pretty soon you're like, oh, everyone else is doing that. And now like I actually have to care about keeping my footprint down. And I'm like, it's just a thing. Yeah, it's a thing that happens. Now, the motivations behind token maxing, I think, are pretty silly. Like, so the correction against that, maybe is extreme, but yeah, sure, whatever. Yeah. Like it's a resource that only exists in finite quantities. And so if you're going to use it, you should be efficient in your usage about it. Oh, I don't know. Sure.
Yeah. And I hope I'm being consistent with this. Whenever this comes up with in conversations, what I say is like, the only thing I hope that doesn't happen is, as you said, the extreme. Like we went from token maxing and everybody was thinking that was this huge flex or whatever. And then now our industry tends to do these just massive corrections back the other way. It's this pendulum thing, right? So I don't want the pendulum to swing so far, like where we're like token optimizing down to the minutest level. And it's like, oh, I only use 3 tokens to write this whole program. Like it's going to lose its utility. Like there's a balance, and everything is a balance. And I think we need to quickly converge on a balance instead of these extremes with this one, especially because I don't want to go through, because we work for clients, and I don't want to go through a time where I'm having to be like, oh, wait a minute, you could have used 500 tokens instead of 700 on this, to write this function. Like we got stuff to do. We got bigger fish to fry.
Yeah.
I don't know. And if it costs that daggone much, like we shouldn't be even using it anyway.
I mean, I think there's so many interesting things to talk about here, because it's, for one thing, we've only scratched the surface. This is like a 90-minute conversation we could have, but I'll just say quickly, like we've only scratched the surface of different models, different levels of quality, different levels of expense. You can run open weight models very cheaply, and you can send a lot of tokens to them. And if you're running them yourself, you're not paying per token. You're renting hardware from AWS. You can run it on like 3rd generation hardware and not pay that much to AWS. And so like, what would you serve with those? Well, there's probably a whole class of workloads where you don't need the latest and greatest model. Have your agent talk to the cheap thing. Okay, so now that price has really gone down. Well, if I've got a human though who's like using Claude and is like deep in thought and like advancing that, well, okay, I want them to have the absolute best experience. So like, we'll pay the big bucks for that. So just various QoS levels, levels of quality. I think there's all sort of, we're just scratching the surface of that, and I think it's going to be super interesting to see how that evolves.
Yeah, I think you brought up GLM 5.2, an open weight kind of stuff, that whole idea. I think that conversation had changed, and I think it changed within the last few weeks when we went dark on Fable for a little bit. Then GLM came out with the open weight models.
What great timing for that.
Yeah, that was how fortuitous.
Here you go.
Yeah. Oh, you can't use Fable? Well, let me show you this open weight model. That's almost as good, right? I think the conversation has changed dramatically, and I'm with you. I think there's going to be situations where the open weight stuff, as you said, it's not trivial to set up, but it's going to get easier and easier. It wasn't easy to run Kubernetes when it first came out either, but now I can spin one up in Azure in like 5 minutes. I think it's going to get easier and easier to run this and run your own inference with these open weight models. and they're good enough for a lot of stuff. I don't need, what's the weather in San Francisco going to be like? I don't need to send that to Fable, right? Like I can ask an open weight model, those sort of things, right? I'm with you. I think that routing to the right thing. I did notice. I was talking to somebody last week about this. I used the Claude Superpowers plugin, and I did notice that it's consciously choosing models based on the task at hand, which is really cool. And so if you throw GLM into that mix where it has that as an option of like, oh, I can offload to a cheap model. Yeah, I think we're going to be doing a lot better on this token thing. So yeah, I'm with you.
Part of the reason I'm so excited about this is also like, I think this is a big opportunity for Buoyant. And so a lot of the stuff that we're starting to work on, which by the way is not released at all, coming soon, is around how do you run inference really efficiently and economically in Kubernetes, and how do you do it for the I don't want to say the lower constraints. If I want an agent running, and I don't care about sending it to the most powerful model,
right?
How do I do that? You can do it pretty easily.
Yeah. That's what I'm saying. Like, it's getting easier. The only thing that came up in my research was like, especially GLM, like their default way of getting it stood up and everything was you would download Python code from a Chinese company, and there's a little bit of weirdness there that you got to be careful of. But like if you're using a standard harness that just a way to run these open weight models, and you say, here's the architecture of the network, here's all the weights and files and zippity doodah. Yeah, like that's going to be, again, next year we're going to be talking about this is like nothing, right? Like when Buoyant releases their awesomeness, we're all going to be like, hey, just spin this up using Buoyant's product.
That's right. That's right, James.
That's what I'll be saying. I'll be like, that's cute. Worried about my own inference. Buoyant made it so easy. All right, so let's that's it for the ship it or skip it. Our next segment of the show. And if you're a friend of the show, or if you've listened to the show before, you know that this is the most important segment of the show. This is what we call the lightning round.
It's time for the lightning round. Rapid fire, don't slow down. Answer quick and make it count. In this game, there's no way out. It's time for the lightning round.
This is where all the things we've talked about before, whatever. Nobody really cares about that stuff. This is what people tune in for. This is where the answers start to matter. There's actually there's a score involved here. We do send it through an algorithm to grade you on your answers. There are right and wrong answers to these questions. And this is the stakes are much higher in this round than they have been so far. So
what do I get with a high score? I get like a prize?
To be determined. Yeah, it depends on you go to like Dave & Buster's and you hit the jackpot, you can buy like a Rubik's Cube. But if you're not, you don't have a great night, you're walking out with a spider ring. It's one of those kind of things.
Right.
So yeah,
so I get tickets that I can exchange.
Right, exactly. Now, if you come on a bunch of times, you can stock up your tickets and maybe get that Hello Kitty doll that's sitting up at the top. I'm making this up. I have no idea. I haven't been to Dave & Buster's in forever. I'm just making things up at this point. But just suffice it to say, this is important, and you'll realize once we get into the questions, you'll see what I'm talking about, how we really take it up a notch. Are you ready? Are you mentally prepared for the lightning round?
Ready.
Okay. Do you snore?
Yes.
That's a loaded question. I have a list here. Let's see. Have you ever worn?
If you give me like 20 minutes,
the loaded question that I won't ask you.
Just keep talking, and I'll I'll just gently drift into a slumber, James.
The question was, who has it easier, men or women? I'm not doing that to you, man. No way. That's crazy. What kind of question is that? How about have you ever worn socks with sandals?
No.
God. Good. What's your favorite type of tea?
Oolong. Formosan oolong, especially stuff you grow it on the high mountainsides. Get the little monkeys to pick it.
Is that how it works?
Yeah,
that's a thing.
Yeah, it's called monkey picked tea. It's
I've got to get into this. I I would feel very important. Yeah, I have monkeys that pick tea for me. I would feel very important if that's what I drank a lot of.
I mean, I'm just buying the tea. I'm not leasing.
You're not directing the monkeys, and you don't have a cadre of monkeys that do. Okay, I get it. Are you a Godfather or Star Wars kind of guy?
I am a Star Wars guy with a very specific restriction, which is I only go up to 1983.
That's fair.
Produced after 1983. I don't look at it.
So that doesn't include Jedi.
Oh no, maybe it's 84. Well, I do want to include Jedi.
Okay, so Jedi. I don't know the year. I'm just guessing. I didn't know.
Okay.
You do include the original trilogy. You draw the line after that.
That's right.
I always tell people my favorite is definitely Empire. That's my favorite one of all time. I loved Empire Strikes Back, but Okay. Do you like the smell of gasoline?
No, not really.
Not in particular. Okay.
With with maybe a minor exception if you get a good Riesling, Riesling like the type of wine.
Yeah.
Get one with some age on it. There's the classic description is you'll have notes of petrol. What they very poetically call notes of petrol.
Notes of petrol in a Riesling.
But it's not like smelling a gasoline can.
That's not like you're not going to be guzzling out of the tank. There,
take a Riesling, yeah.
There you go. Have you ever seen a kangaroo in person?
I don't think so. Maybe at a zoo when I was.
I think at a zoo would that qualify as in person? I think we would accept that as being in person.
We're both there in person.
I've never fought one. Like you see those videos of the guys like punching them. I've never done that, but I have seen them.
That's really impressive because they look muscular as heck.
Yeah, they buff up. Yeah. I don't think I'd mess with one of them. Polka dots or stripes?
Probably stripes.
Stripes. Most embarrassing store you might be seen shopping at?
Boy, embarrassing store. I mean, that I would shop at in person?
Yeah, we'll go with that.
Yeah, I don't know. There's not a lot that embarrasses me.
I have 3 daughters. I would get my guess. My answer would probably be something like Sephora. Like if somebody saw me in Sephora, I mean, they would understand because I have 3 daughters. But I just feel like me being in there is it's just weird for me to be there.
It's not weird. I think that's sweet.
They have men's products and stuff there, but I don't know. That would be probably.
You're shopping for your daughters. I mean, it would be embarrassed.
It's not weird, but people.
Yeah, I don't have a great. I'm not embarrassed by anything I do.
That's fair.
Other than this podcast.
Oh, wow. All right. Scale of 1 to 10. How good are you at trivia?
I'm really bad. Like
are
3.
You? 3? Okay.
Yeah. A lot of trivia is like what's happening in the world or what has happened, since like the 80s. And I'm just like oblivious to so much of that. Unless it's like Kubernetes or, something. I'd be good at Kubernetes trivia.
If they had like a bar night and it was like, Kubernetes trivia. And you're like, we're not going anywhere.
I'd be the king of that thing. I'd be the only one there.
That's right. Yeah. All right. Let's see if we get a couple more here. How long can you hold your breath?
Could probably go 50 plus seconds.
50 plus seconds. That feels respectable. I don't know what the average is, but that feels respectable. Okay. One more. How many times do you think you have sneezed in the last 7 days?
Oh boy, I had like a little allergy attack a couple days ago, so probably like 40.
40. Okay.
You could go 3 days back and it'd be like 30, 38.
Okay. All right. Well, that's it. That's our final lightning round question.
Should the sneezing be higher or lower?
I don't know. The algorithm will tell. We'll see how you did when the algorithm parses through all of it. I don't know. I don't know the answer to that. I don't know how many times I've sneezed in the past. I'd say in the past 7 days, I'd have to guess like a dozen. But I haven't had any allergy problems in the last 7 days. So maybe that's the thing. All right. Well, that is it for the lightning round. getting ready to close out here. Anything you've got coming up, Buoyant? I mean, you mentioned something with Buoyant coming up, but anything you have, like, are you speaking anywhere? You have any books coming out? You got a one-man show on Broadway kind of thing? Anything, or what is Buoyant working on that you'd like to share? Anything coming up?
Yeah.
Hot off the press?
So, well, for one, if you're running, if anyone out there is running Kubernetes, I'd love to talk to you about Linkerd or service meshes. We have a new release out that has all sorts of exciting features, just a week or two old, including support for Windows. So if you're like running both Kubernetes and have legacy Windows applications, so we got some cool stuff for you. We're heavily invested in inference serving on Kubernetes, and so we'll be talking a lot about that coming up, but I don't have anything to point you at just yet, other than, like, I don't know, I guess you could follow me on LinkedIn. Boy, what an embarrassing thing to say. Yeah, follow me on LinkedIn, and that's probably where you'll hear about it. Yeah, other than that, we'll be at KubeCon. We're always at KubeCon. So.
Always at KubeCon. Yeah. At least you're not saying Facebook. Like, follow me on Facebook, because my daughters cringe if I ever say anything about Facebook. Like, but I'm in the group of people that, like, we did communicate over Facebook, so you still have these groups and parent things and all that. But my daughter's like, oh gosh, that's old people.
I was on Twitter for a long time. I used to say follow me on Twitter, but not there anymore.
Not there anymore. I mean, it's not even called Twitter anymore. It's now X, but we still say tweeting. That blows my mind. I don't understand.
I still call it Twitter, and I shed a little tear.
I understand. It'll always be Twitter to me. Okay. And any books or anything speaking? I mean, I know you said you're going to KubeCon, anything like that?
I'll be at DevOps Days in New York, I think, next month. Other than that, just working away on fun service mesh stuff.
Well, it has been a joy. It was a lot of fun. We had a lot of laughs. It was very informative. Really cool stories about Twitter and the birth of service meshes and Linkerd. I really enjoyed this conversation. Thank you very much for coming on.
Absolutely. I enjoyed it as well. So thanks for having me, James.
Yeah, good time. Well, if you'd like to get in touch with us, drop us a line at /@Calibrity.com. See you next time. The / podcast is created by Calibrity. The / team is director and producer Ryan Wilson, editing by Steve Baradelli, marketing support by Taylor Blessing, and I'm your host, James Carman. Thanks for listening.